Right, so now we've determined that my angle lies in quadrant 3, okay? So I've determined that my angle lies in quadrant 3. And I'm gonna keep going from there, okay? All right, so I'm given cotangent. I need sine and cosine. So I go to my list of identities. I could use any of these identities to do this. More often than not, you're going to have more than one choice, okay? So I need an identity that relates cotangent to either sine or cosine. Now, look at this one. This one relates cotangent to cosine and sine. But of the 3 players in that identity, I'm only given cotangent and I have 2 unknowns. So that's not a good one to use. Another one I could use is this one here at the bottom. Because this one has cotangent and cosecant, which is like sine, but there is one known and only one unknown in that equation. So that's a better one to use. Yeah.
So because that equation would be cotangent theta, and we just know what the cotangent is, would it be 4?
Yes, sir. Yep. Okay, so we're going to use cotangent squared theta plus 1 equals cosecant squared theta. Okay. So, like Benny just told us, we know that cotangent is 2. Cotangent squared is 2 squared plus 1 equals cosecant squared theta. So this is 5 equals cosecant squared theta. And now I take a square root. I take a square root. What's cosecant of theta equal to? Just root 5? What happens when you take a square root of both sides? Plus or minus root 5. Okay, plus or minus root 5. Okay, now, this tells me I have 2 choices, either positive or negative. Remember how we figured out that this angle was in quadrant 3? In quadrant 3, is cosecant positive or negative?
Negative.
Negative. So I take the negative. So I say cosecant of theta is negative root 5, which is fine, but I don't even want cosecant. I want sine. So sine of theta is negative 1 over root 5. Okay, yeah. Yes. Okay. Now I need to find cosine. Okay. I have sine. I need to find cosine. I also have cotangent, which means I have tangent, right? So I have tangent, cotangent, sine, cosecant. I need cosine. So now look. If you have sine and you want to find cosine, this is totally acceptable to use. In this case, not only do we have sine, we also have tangent, so that's also acceptable to use, right? And it's up to you which one you want to do. I want to go with the tangent this time just because it's less math, okay? So I say tangent of theta is sine theta over cosine theta. Okay.
Wait, is there other one?
Check out what you could also do. This one is just like multiplying fractions. Check out what you could also do. Cotangent of theta is cosine over sine. Okay, let's use this one. What's cotangent? 2 equals cosine over sine negative 1 over root 5. So now I'm going to multiply both sides by negative 1 over root 5. So whenever you have something in the denominator and you want to get rid of it, you multiply both sides by, the whole denominator. And so what's cosine? Negative 2 over root 5. Okay, questions? Yeah.
For the homework, if we have a problem like that, do we have to fill all the options we
No.
can use?
No. Just pick one and use it. Okay?
Yep.
Okay. All right. So here's a question for you, back from chapter 4. Yeah. What's sine of 30? 1/2. What's cosine of 60? 1/2. Okay. What's sine of 60? What's cosine of 30? Okay. What's secant of 30? 2 over root 3. What's cosecant of 60? It is 2 over root 3. Okay. Okay, 3 examples here. Let's say the trig function. Sine, cosine, sine, cosine. So this is the co of this. Secant, cosecant. This is the co of this. They have equal values. What do you notice about the angles? They do flip.
It's 30 and 60.
What do they add up to?
90.
90. They're complementary. 90. They're complementary. Okay? So now, these are called co-function identities, right? So we've always been saying sine is the reciprocal of cosecant, but then what's up with all the cos? Why is it sine and why is it called cosine? Like, why are they buddies like that? Why is it called secant and then why is it called cosecant? It's like they're partners. This is why they're co-functions. So the co-functions have equal value when their angles are complementary. Okay? So suppose, oh my, somebody turn that off. So suppose, okay, who has their calculator up? Who can tell me what sine of 50 is? Degrees.
Sine.
50 degrees.
0.7660.
0.7660. Okay? So now, here's my question. Cosine of what is 0.7660? 40. Thank you for raising your hand. 40. Okay? All right. So, how did we get this? It was 90 minus 50. Okay. 90 minus 50, that's how we got 40. So now, if my angle was given in radian, right, and that was theta, how would I find what goes in here in radian? It wouldn't be 90 minus the angle. It would be what minus the angle in radian? Pi over 2 minus the angle. So, cosine of pi over 2 minus the angle is the same as sine of the angle. Right? Tangent of theta is the same as cotangent pi over 2 minus theta. All right? Okay, so those are co-functions. Now, so just make sure that, these are complementary. Okay, let's talk about even and odd identities. Again, we touched on this last time, right? This is why I was giving you all those secant of theta, secant of negative theta. So, Remember what we talked about in chapter 4. If I have an angle here, okay, what could be a possible, okay, so let me ask you this way. Could 1, 3 be a possible coordinate for where this angle intercepts the unit circle? It can, right? X is 1, y equals 3. It can, all right? It might not be a special angle, but there could be an angle that hits it at 1, 3, right? Okay, so that's theta. Now, if I move to negative theta, what would this coordinate point be? What would the x value be? 1, -3. Okay? And so now, if our x value is cosine and our y value is sine, then in going from an angle to its negative, the cosine stays the same. So in going from an angle to its negative, the cosine stays the same. So whether you have cosine of theta or cosine of negative theta, same value, 1 and 1. The sine, however, will also go between positive and negative. So if I go from an angle to its negative angle, the value of the sine will switch sign, and that's an unfortunate use of like the, sine and sine. Okay, so if I go from theta to negative theta, the value of the sine will also go back and forth between positive and negative. Okay? Tangent also has to switch sign. Because look, what's tangent of theta here in my example in purple? What's tangent of theta? 3. What's tangent of negative theta? Negative 3. It's got to be that way because the y value is changing, to negative. Yeah.
Is negative sine of negative theta equal to sine of theta?
Yes. Okay, so let's do this. Cosine of x is negative 0.75. Okay? What I want is sine of x minus pi over 2. Okay, so what does this remind you of? That reminds me of cofunction identities, right? Pi over 2 minus or plus. So now, here is what I say. Okay, if cosine is negative 0.75, that's the same as sine pi over 2 minus x, right? That's equal to negative 0.75. Okay? Everybody okay with this? Is this what we want? No. We want x minus pi over 2. But this is pi over 2 minus x. How are these related? Huh?
Oh, you distribute the negative. There's a term.
It's a negative. One is the negative of the other. One is the negative of the other. So this is the same as, so this is the negative of the angle here. So this is sine of negative x minus pi over 2. Right? So basically, let's write it that way. This is sine of negative theta. Okay?
Why did you put that one in brackets? Does that mean a different thing?
No, not really. I was going to do something else. So that's the same as sine of negative theta. Here, just to please Savan here.
No.
Okay?
Making sure.
So when in sine, when the angle becomes negative, what happens to the value? Negative of the negative, which is positive 0.75. So what does negative mean? What does it mean that something becomes negative? All it means is it switches sign. Okay? Becoming negative, the negative of something just means opposite sign. Okay? I wish like in elementary or in middle school, teachers did a better job of that. But negative just means opposite sign. Opposite S-I-G-N. Okay.
Oh.
Okay. Let's go. All right.
He said nothing involving this.
Okay. So let's go to this. This page is more of the stuff that we'll see in this chapter. So let's do it. Now, I have to give you fair warning. Okay, the word simplify, I get it, can be rather open-ended because how do you know how simplified is simplified? So, over the years, for our purposes, I've tried to define it, at least in my class, that when I say simplify these trig functions, you want to put them into sines or cosines, right? And as reduced as possible, okay? Now, there are a few strategies. One strategy is start by rewriting in terms of one trig function or in terms of sine and cosine only. Another trick is use identities where possible. Okay, now, in the beginning, it'll seem like, oh my God, I have this problem. I don't know where to go. The more you do it, the more patterns you will see. So please allow me to do a couple and then I will take questions. Okay, now, a couple of things to look for. One is this. If you have a trig function squared plus or minus a 1, that should always set off the alarms for the Pythagorean identities, okay? Now, I have here sine squared with a 1. I think to myself, oh my God, that totally looks like the first Pythagorean identity. So, let's write down this Pythagorean identity equals 1. Okay, these are not rigid objects. They're fluid. You can move them around, right? Meaning, why don't we, just for fun, subtract sine squared x from both sides? Now what do I have? Cosine squared x is 1 minus sine squared x. So now let's go back to our problem. I'm going to leave this untouched. I'm just going to rewrite it. But look at this, guys. 1 minus sine squared x. Look, what is that equal to? Cosine squared x. So you replace it with cosine squared x. Isn't that cool? So now, what's cosine squared x? That's like cosine times cosine, right? So I can cancel out one cosine from here and from here. And the answer is just cosine x. Remember to put your... You can't, because cosine of x is one entity. It's like if you had x plus 1 over x, you couldn't cancel out the x's, right? Okay. So that's that. So that's one strategy, using a Pythagorean identity. Another very, very useful strategy is to see if you can factor anything out. Ask yourself, can I factor out a term? Well, if I wrote it down right next to this problem, you can obviously factor something out, right? So, actually, you know what? Before I do that, here's what I'm going to do. First, I'm going to change this tangent into sine over cosine. Because remember what we initially highlighted? Start by writing things in terms of sine and cosine. So, here I have cosine x times sine x over cosine x minus sine x cosine squared x. I'll color code as much as I can so you guys see where the changes are. What can cancel out here? How gratifying is that? So now I have sine x minus sine x cosine squared x. Now can I factor out a term?
Yeah.
I can factor out a sine x.
Wouldn't it be just cosine x instead of cosine squared x?
No, because it's cosine. I never changed the cosine squared x from up here.
What if you factor out?
Okay, so when we factor out from the first one, I get 1 minus cosine squared x. Uh-oh, what is that? That's a Pythagorean identity. So, sine squared x plus cosine squared x equals 1.
Wait.
That's just the identity that I'm writing here from the previous page. So now, if I subtract cosine squared x, sine squared x is 1 minus cosine squared x. So here, I write that this is equal to sine x times what? Times sine squared x. And what's 1 sine times sine squared? Sine cubed x.
I have one question.
Is that the answer?
Yep. Okay, very quickly because I
How
want
did
to
you get
finish this.
negative sine x to turn into 1? You got sine x minus sine x plus sine x squared x.
No, I didn't. I factored it out. I factored it out. So I had this, right? I factor out a sine x. That means
I get it.
What is the arrow doing? Like I know it's pointing.
I'm just like rewriting it over there. That's all. I just moved the writing over there.
Sine x. Sine.
1 minus
cosine squared x is.
Okay. So let's do this next one. Okay. Okay. This one. You have a fraction plus or minus another fraction. You have to do common denominator. All right? So to do common denominator here, you can do it any which way you like. One way to do common denominator is I can multiply the first fraction by 1 plus secant x, top and bottom. And then here I multiply by 1 minus secant x, right? Top and bottom. So what I have in the numerator is secant x 1 plus secant x minus secant x 1 minus secant x. Okay. I'm just rewriting now. In the bottom, what do I have? 1 plus secant x, 1 minus secant x. Okay. Now what you're going to do is you're going to distribute. So I'm going to get secant x plus secant squared x minus secant x plus secant squared x over, okay, 1 plus secant, 1 minus secant, that's a plus b, a minus b, 1 minus secant squared x. Yeah.
Is secant squared x plus secant squared x?
Yes, it is. Okay, so now secant minus secant goes away. So what I have on top is 2 secant x over this. Oh, yes. Now, what's 1 minus secant squared x? Is there an identity?
Yeah. It's gotta be.
1 minus secant squared x. Is it tangent?
Negative. Yeah.
It's negative tangent.
Wait, no, wouldn't that be secant squared x minus 1?
Okay, so look, very quickly, let's do this. And then, so tangent squared theta plus 1 is equal to secant squared theta.
Yeah.
1 minus secant squared equals negative tangent squared theta. So this is going to be 2 secant squared theta over negative tangent squared theta x. Okay, so here I have 2 secant squared x, which is 2 times secant squared is 1 over cosine squared x over negative tangent squared x, which is negative sine squared x over cosine squared x. Okay, so here we can cancel out a cosine squared from the top and a cosine squared from the bottom because identical denominators will go away. So what I have is, in the numerator, I have 2. In the denominator, negative sine squared x, which is the same as negative 2 cosecant squared x. And both of these are equally acceptable. Okay, so for this next one, in the numerator, I have 1 plus tangent squared x. And as I told you, if I see a trig function squared in conjunction with plus or minus 1, then that's an identity. So if we go up here, 1 plus tangent squared is secant squared theta. So that's this one. So here I say 1 plus tangent squared, that's secant squared x over cosecant squared x. So again, in the numerator, I have 1 over cosine squared x. Remember, we always have to simplify things so that they're in terms of simplified sines and cosines only. In the denominator, cosecant squared x is 1 over sine squared x. So this is 1 over cosine squared x times the reciprocal sine squared x over 1. Together, that's either sine squared x over cosine squared x or tangent squared x. Again, both of these are acceptable. Okay, in the case of the last one, so here I have ln of something minus ln of something else. And in Algebra 2, you learn ln of A minus ln of B is equal to ln of A over B. So ln of a quantity minus ln of a second quantity is ln of the quotient. Okay, so one other thing here, when you have the absolute values around sine and cosine, that's because the term inside the ln must always be positive. And as we know, sine and cosine are positive half the time and negative half the time. So we have to put absolute values so that we only take the positive values of those. Okay, so this is going to be ln of A over B. So that'll be ln of sine x over cosine x. And because sine x over cosine x still sometimes is positive and sometimes is negative, we have to put parentheses, absolute values around it. So that's, so much for that. In case you encounter some other examples of this, so let's just suppose you had ln of sine squared x, something like this. Now in this case, you have ln of, this is the same as ln of sine of x squared. And because sine is being squared, then it already is positive, so there is no need for absolute values. Okay, so what you also learn in Algebra 2 is if you have ln of A squared, the exponent will come down, so it'll just be 2 ln of A. So in this case, this will just be ln of sine x, but the 2 will come down, so it'll be 2 ln of sine x. Okay, similarly, what if you have ln of cosecant x, or better yet, cosecant squared x? Well, notice this is the same as ln of 1 over sine squared x. Oh, and by the way, in the top here, when you move the 2 down, this needs absolute values. So going back here, ln of sine squared x. Now, we also know that this is the same as if I were to write ln of sine of x to the negative 2, right? Because 1 over something squared is the same as that to the negative 2. So now I can bring that negative 2 down, and this will be negative 2 ln sine x. So you'll encounter that on your homework, I believe. Okay, so this homework is due for H period Friday, tomorrow. Thank you.